All right, for number 1, it says in parallelogram MNPT, angle M is this polynomial and angle N is this polynomial. How many degrees is angle T? So remember, a parallelogram means that the opposite sides are parallel. So I normally will draw a picture in this situation. So we have MNPT. It doesn't really matter how you label them as long as you go in order based off of what it says here. Now, angle M, it says, is 6x plus 10. And then it says angle N is 5x plus 10.5. Now, some things you need to know in a parallelogram. Opposite angles are congruent in a parallelogram. But adjacent angles, which angles are side by side, they're supplementary. So in this particular problem, since they're side by side, we know that angle M plus angle N equals 180 degrees. So we can set up an equation here. Now, they want us to find angle T. Well, if they want us to find angle T, that means that once we find angle N, those two are congruent to each other. So the first thing we got to do is we got to solve for x. So we're going to set up the equation. So we have 6x plus 10 plus 5x plus 10.5 equals 180 degrees. Now, we're going to combine like terms, and that's going to give me 11x. So 10 plus 10.5 is going to give me 20.5 equals 180. So we're going to subtract that 20.5, and we get 11x is equal to, and that's going to be 159.5. Now we're going to need to divide by 11. So if we divide by 11, we get 159.5 divided by 11, and we get 14.5. So x equals 14.5. Now, with that being said, we can plug in the 14.5. So let me move that over. So we can take the 14.5 and we're going to plug it in for the x here. And once we plug it in for x, we find n. And if we find n, we find t. So this is going to be 5 times 14.5 plus 10.5. And again, you can plug that right into Desmos. So we get 14.5 plus 10.5, and we get 83 degrees. Now, 83 degrees, again, is the measurement of n. So if we find the measurement of n, we find the measurement of t. So the degrees of t is equal to 83 degrees as my final answer. All right, so for number 2. So again, we have a rectangle. A rectangle is also a parallelogram, and we have diagonals. Well, the diagonals in a parallelogram, especially in a rectangle, they intersect at E. Now, they tell us that IE, so IE is right here, and we have G or EG. So in this situation, this is 3x plus 4, and this one is 5x minus 6. So when they intersect, this E right here, E is the midpoint. So when we have a rectangle like that, and we have diagonals, E is the midpoint. So if it's the midpoint, that means that we know that these two are equal, and we can set up the equation. Now, this problem is asking me to find the length of FH. Well, let's change that color. So FH. So if I can find the length, or find x, and then I plug x in for one of those, then we know that they're the same. If I can find the length of x, and I can find the length of the other two, then this is also going to be the same. Okay? So I'm going to solve the equation. So I'm going to subtract 3x so I don't have any negatives. and that is going to give me 4 equals 2x minus 6. I'm going to add 6. And then 2x equals 10. So we know x equals 5. So again, I'm now going to take what x is equal to, and I'm going to take 5, and I'm going to plug it in for x. So this is going to give me 3 times 5 plus 4. So 3 times 5 is 15 plus 4 equals 19. So this section right here is 19. Well, if that's 19, then this section is also 19. So 19 plus 19 is going to give me 38. Now, if I know the whole thing is 38, then that from I to H. So I to H is 38. Well, I to H, so I and H is equal to F to H. Or sorry, not I to H, I to G. I to G is equal F to H. So since I to H is I to G is 38, that means F to H is 38. Now, we haven't talked about statistics, but I think with these problems you'll be okay if you really just think about it in a common sense format. It says, which method is most likely to produce a random sample of 5 students? So remember the keyword random. So when you are selecting students, if I go and I select students and I want students that have a GPA of higher than 3, and I go to our class, obviously that's not going to be a random sample because our class is an honors class. So most likely there's going to be more students with a GPA that's higher than a 3.0. So if I were to do a random sample, then I would choose random students within the school, not just one particular class that could potentially be an honors class or not an honors class, because that may be the difference. So a random sample is picking from a population that would produce random samples, not necessarily samples that are particular to that group. So we want a random sample of students from a school club. So it says which one would most likely. So selecting 5 club members who have brown hair, selecting the 5 club members who have raised the most funds for the club, selecting 5 club members from a hat containing the names of all the members, and then selecting 5 club members who arrive last to a club meeting. Well, by selecting 5 members who have brown hair, that's not really random. That's selecting people with brown hair. So that one kind of takes that out. Then we have 5 club members who were raised the most funds. Well, if they raised the most funds, they're probably the most dedicated club members, so that's not going to be random. Then with D, it says selecting 5 club members who arrive last to the club meeting. And that's not necessarily going to be random because it may be a whole group of people that are always together. So the ones that are random are going to be picking from a hat, and that's random because you're putting all the group members in the hat, you're randomly picking them out, so making that C. All right, so we've talked about this one before. If you want to find the radius of the circle, you're going to put this into Desmos, and we're actually going to graph and look at what we have. So we have 4x minus 4y plus 4 equals 0. Now we'll move that over just a little bit. We can see that the center of the circle is at 2, 2. So from the center to the outside, that's going to be 2 units. So the radius is 2 units. All right, so this one, it talks about margin of error for statistics, but really this problem is just about plugging in what they've told you each thing represents and then finding the number. So the margin of error basically kind of has to do with the random sample. So again, if I pick students from one particular class to see how many students have a GPA of 3.0 or higher, the margin of error is going to be higher because I'm not picking a random sample. So if I want to have a margin of error, I want to pick a larger population to reduce the error, and I want to pick random. But in this particular situation, we're just looking at, it says the high school randomly selected 75 of 200 seniors at the school to take a sample college entrance exam. The mean grade of the GPA of the students was 2.85, and the standard deviation was 0.4. Now, they want to know what is the margin of error and which statement is true. So the great thing here is they give you the formula, and they say that S is the standard deviation and N is the sample size, which they give us both of those. So for margin of error, we have approximately 2, and then we're going to multiply that by the standard deviation. Well, it said the standard deviation was 0.4 divided by the square root of the sample size. Well, the sample size was 75. All right, so if I'm looking at my sample size, so I have 2 times 0.4 divided by the square root of 75. And we get approximately 0.0923 repeating. So when I'm looking at this, it says the margin of error mean grade was 0.057. Well, that's not right. Then we get the margin of error mean grade is 0.092. So there we go. There's our margin of error for that particular example. So this one's kind of talking about the same thing. They even give you the margin of error formula again. However, when we talk about margin of error, remember, to reduce your margin of error, so to reduce margin of error, you want to increase your sample, and if you do that, you want to make sure that it is random. All right, so the police chief in town is trying to determine the average speed of drivers on a Pacific road. The police chief took a random sample of speeders of 100 drivers. So it was random, which is good. The mean driving speed was 48.5 miles per hour with a standard deviation of 2.5 miles per hour. The police chief wanted to decrease the margin of error. So to reduce that margin of error, what can he do? Well, they give you the formula, but again, you really don't need the formula. It says changing the time the data is collected. That's not going to make it random, so that takes C out. Changing the road, that's not what he wanted. If he changes the road, then he's completely changing what he was talking about because he wanted a very specific road. So the question is, do we decrease the sample size or we increase it? Well, we increase the sample size because if we increase the sample size, that's going to reduce the margin of error. So instead of doing 100 drivers, he may do 200 drivers. And that's going to help him get a better selection of what he's actually trying to find. So B is the correct answer. All right, so for 7, find the solution. So remember, when we do solutions, you create 2 equations that are y equals equations. So we have y equals, we have 2x minus 3, and we're going to divide that by x minus 1, and then y equals 8x plus 1, and then 4x plus 5. And we find the intersections. So let me get our graph a little bit bigger here. So we see over here that these are leveling out at a horizontal asymptote. We have some other things happening, but we see there's an intersection right here. So we get 2.8. So we can get rid of the negatives. That's gone. So which one is the correct answer? So we have 14 divided by 9. That's 1.55. 14 divided by 5. That's 2.8. So the correct answer is D. All right, for number 8, it says the function models the value of an investment after T years. So that's super important that it says it's in years. Based on the function, what is the approximate monthly interest rate? So if you remember, we look at the base, and that base shows me that it's growth because it's greater than 1. And if we find the yearly rate of increase, we would say 1.20. We're going to multiply that by 100 to turn into a percentage, and you get 120%. Now, the rate that it's increasing every year is going to be the difference from 100. So we're going to subtract that, and we know that the yearly rate, the yearly rate is going to be 20%. But we don't want the yearly rate, we want the monthly rate. So to find the monthly rate, we're going to divide this by 100, or excuse me, by 12, because there's 12 months in a year. And if we do 20 divided by 12, that gives me approximately, we have 1.6%. So if we were to look at this one, we would have the answer as C. That would be the closest one. All right, and then number 9, it says, a reporter wants to know the percentage of voters in the state who support building a new highway. What is the reporter's population? So population is like what you're pulling from. So if you pull a random sample, the population is the, I guess, the pot in which you're pulling from. So we don't want to know just particular people. We want to know, where is he pulling from? Well, what is he talking about? The percentage of voters in the state. So he's pulling from voters in the state. So the number of people who live in the state, the number of people who are interviewed in the state. So just because they were interviewed in the state doesn't necessarily mean that they live in the state. All voters over 25. Well, why would it just be voters over 25? You know, you can vote at 18. All eligible voters in the state. So if the number of people who live in the state, so you're kind of, in my opinion, you're looking between A and D. Well, the number of people who live in the state doesn't necessarily mean that they can vote. So he's only talking about people that he's going to pull from that can vote. You could have people in the state that can't vote. So we're going to get rid of A, and we're going to look at all of the eligible voters, or what he's pulling from. And then the last one, number 10. It's a division problem. A lot of you are doing these graphically, which I'm fine with. Just be careful. Make sure that you're typing everything in correctly. So we have plus 4x minus 21. And we're dividing that by x plus 5, and then x squared plus 8x plus 15. So you get this graph. So the question is, which one matches that? Well, we have the first one. That's going to be x plus 3, x minus 3. And actually that one matches perfectly. So the correct answer there would be A. Now, if you were doing this by hand, you would actually factor, and then you would flip it. So the first thing you're going to do is you're going to keep, change, flip, because it's division. So this is going to be x plus 7 over x squared plus 4x minus 21. We're going to change it to division and then flip this fraction. And then you would factor. So in this one, we're looking for two numbers that multiply to give you 21, but add to give you 4. So if I'm looking at that, two numbers that multiply to give you 21, but add to give you 4 are going to be 7 and 3. But we got to make sure the 7 is positive and the 3 is negative. Then over here, we're going to have two numbers that multiply to give me 15, but then add to give me 8. That's going to be 3 and 5. So this is going to be x plus 3, x plus 5. All right, and that's going to be over x plus 5. And then you would start canceling things out that are on the top and bottom on either side. So we have x plus 5, x plus 5, x plus 7, x plus 7. Now this one's positive, this one's negative, so you can't cancel those. So basically you have x plus 3 left in the top, x minus 3 in the bottom.